This is a Ditch Witch R40 with a 4-cylinder Wisconsin VG4D. The engine's been rebuilt, it's in good shape. Carburetor, I put a new throttle shaft in it. I use Briggs & Stratton valve guides as bushings instead of the factory ones. They have a wider surface contact, so it works. There's going to be less wear. Also, I took an end mill and bored out the ends, put custom seal in there. Factory seals are kind of got that felt stuff, and they're not very good. These are Chicago Rawhide 2450s that I put in, and I put them with the lips facing out, so the vacuum of the carb pulls lips tight against the shaft. And I got high temperature. This gunk around here is high temperature grease that I keep around there to assure that no dust is going to be sucked in the carb. I keep this choke lever disengaged because it's a bad design where when you pull it back it gets within the area of the steering wheel turning, and it gets bound up. So if I need to choke it, I slide it in there, pull it back, choke it, and let it out, and let it lay there. I've been doing that for last 15 years on this, so there's no problem there. Got a hydraulic pump up front, attaches to the front. Blade here that can be swiveled from side to side to backfill the dirt alongside of a trench. It's got hydraulic cylinder on each side for that. This transmission has none of these transmissions off of these Ditch Witches have ever given me problems. I keep oil in them, keep it changed. I don't have any problems with them at all. This model here has got a lot of the same parts in it as the Ford pickups, some of the Ford pickups from the 70s. It's a 4-speed tranny with plus a reverse. So you got the power. So the power comes off the back of it into this jack shaft area, which is it's all mechanical. As you see, it's a greasy mess, but it's simpler to work on and repair than the newer models. The rubber belts go down to a right angle drive, which works its way on back to the digging shaft. When you have this lever forward, this group of different splines here is what, when they disengage, engage, they do different things. When you have it all the way forward, the trencher's in a driving mode to where you put it in gear and you drive it around like a tractor without running anything other than the wheels. You pull it halfway back, it puts it in the crawl mode, whatever you want to call it, to where this lever here, which is a little hydraulic valve which controls the flow of hydraulic fluid, which will go through this motor, little hydraulic motor underneath the tranny with these splines, and runs this chain, and it will control the wheel speed in a very slow motion mode, and this lever will reverse it, put you in reverse or forward, or a position straight up where the trencher doesn't move. Slide this all the way back, and it engages this pulley, which will turn your digging chain. These splines, you can see, are real good shape. This back spline, just the first 1/8 of an inch you can see has a little bit of roundness to them, but when you engage them fully, it's what needs to be done. Keep them engaged fully, and then there's no problem. These splines will last you a long time. There's nothing going on here that needs replaced. The right angle drive, there's no problems with that. When I change oil in it, there's never been any debris or any sign of anything but slight normal wear. This is your clutch. So this right angle drive comes out of the side of the frame with a sprocket. As you can see the teeth are very nice on this. This chain is like new because it is new. So is this sprocket and this sprocket. Everything yellow here I made from scratch, except the sprocket I bought it as an A-style sprocket, bored it out to fit this steel hub that I machined to a 2 1/4 ID to slip over the 2 1/4 shaft, and I broached 5 ace keys 180 off to fit on that. I made this shaft also, and it's better than what you're going to buy from Ditch Witch, because they take a piece of coil roll and they machine some keyways in it, and there you are. And so coil rolls usually about 3/1000 under the true dimension of 2 1/4, and your internal bearing races are usually about 2/10 over 2 1/4, so you're starting out with over 3/1000 of play. And that same goes with the hub for this drive sprocket. What I did is I took and I didn't use just mild steel when I made this shaft. I used steel called Stress Proof, and I brought the shaft down to a 1/2 thou under 2 1/4, buffed it all out with emery cloth very nicely to where these bearings fit very snug. Everything was a snug fit when I put it together, so you're not starting out with play. The drive hub, the drive sprocket hub, which this is the original one that came off of it, is 2 5 ace keys 180 off. When I made that sprocket, I made it with I took an idea from Ditch Witch when they updated these digging attachments. They had, as you can see, there's a crack going on here and here. That's not why this filled, but it would have filled eventually because of those cracks. But what Ditch Witch did later, when they found out there's a problem, they went with 4 5/16 keys 90 degrees off, and that's what I did on this shaft and with that drive hub, and it has a tighter fit than what you're going to get from the factory. So this digging attachment is going to last as long as you keep grease in it and treat it right. Reason why this failed is because this spacer is original Ditch Witch factory spacer that goes between this bearing and this drive sprocket hub. Anyways, if it's tight against the bearing, and then you have another spacer right here, and you have spacers all the way out to the end of the shaft where you put in this bolt, and that sets a thrust on your 2 tapered bearings that face one another. One's located about right in here, and the other one is right a couple inches from near the end. And so it's kind of like a front wheel bearing. they face one another, and if you tighten up the front wheel of your vehicle too much, it's going to heat up and you're going to have problems. If it's too loose, you're going to get slop going out and it'll eat your seals up, and that's what happened with this here. As you can see, this groove is not supposed to be there. This over time ate a groove. This little chicken thing that they sell is so paper thin that play started happening in there. When the play starts happening, your bearing, you get some side play in the shaft because the bearings are no longer being held in there the way they should, which makes your seals go bye-bye and allows dirt to come in, and then it's just a matter of time, and you know the rest of the story on that. So I took this piece of DOM and machined it. You can see the difference in the wall thickness. I machined it out, and that's what is right here, and a short piece right here. And that's why I went with such an overkill on this big hunk of steel as for a sprocket. And I brought these machine washers all the way to the end. So when I tightened up this big washer with this 3/4 inch bolt, there's nothing that's going to give. While I'm here, these are some teeth that I've got extra of, brand new. Some are never been used. I made these out of a chromoly, heat treated them, got them up to a higher Rockwell than any of the dealers sell, and they don't crack, and they the abrasion on them is better than you buy from the factory, and they're elevated, so they're going to do the work above your cup teeth. You can't buy them that way. They sell them at the same height as your cup teeth. I like the bullet tooth higher than your cup tooth. Let it do the breakup work, and the cup tooth bring the dirt out. So as I was saying, there's another bearing here, and you see grease all over right here, and there would be grease here also. It's the exact same setup, because this is for your boom to slide over. If you want to take, what you do is you slide your boom off, which is a lot of work, put it over here, take this auger off, and you can dig alongside of a wall, as you can see, or get up close to something. I've never used it since I rebuilt this digging shaft, or this digging attachment, because I use this trencher mainly for footings on buildings. This grease is meant to be here because it's a purge type deal. This from here to here is like an enclosed housing with your shaft running through there, and you pump the whole thing up with grease. The grease zerk is right here, and you need to keep grease in there. It takes a couple tubes of grease in there to fill it up, and then you need to put a couple pumps of grease in it about every hour when you're trenching. Stop it, just put a couple pumps in there, and it will push the seals. There's some seals in here, right about in here and here, and the lips are facing out, and the grease is meant to go out to push the dirt away. And if the lips of the seals were facing in, you wouldn't be able to purge it like that, and dirt would easily come in. So the lips are out. You got a mess going on all the time with grease here, but that's the way it needs to be, and it's the way it was designed. I'm going to stop this video, and then I'm going to pick up on another one right after it.